Momentum, p, is the product of mass and the velocity of an object. You can think of it as how hard it is to stop an object moving at the direction of its velocity. The measurement of momentum is kilograms times meters per second. For example, an object that weighs 10 kilograms traveling at the speed of 10 meters per second will have a momentum of 10 times 10, 100 kilograms meters per second. The cool thing about momentum is that it can be conserved. For example, say an 1 kilogram toy car is moving at 10 meters per second on a frictionless floor. Its P is 10 kilograms meters per second. When you add a 4 kilograms object onto the car, its mass becomes 5 kilograms. Therefore, after adding the object, its velocity will become 2 meters per second because P is the same before and after the addition of the object. The P before the object added was 10 kilograms meters per second because mass is 1, velocity is 10, 1 times 10. When the object was added, the mass becomes 5, and to find its velocity, we do 5v equals to 10, and the velocity is 2 meters per second. For another example, let's say there are two balls. One ball is 10 kilograms, and the other is 5 kilograms. The bigger ball is moving at 2 meters per second, while the smaller ball is at rest, which is 0 meters per second. The total momentum is 20 kilograms meters per second, because the bigger ball's momentum is 10 times 2, 20 kilograms meters per second, plus the smaller ball's momentum, which is 0 times 5, 0 kilograms meters per second. And let's say the bigger ball hits the smaller ball, and the bigger ball comes to a complete stop. This means that the smaller ball is moving at a velocity, and we need to calculate the velocity of the small ball after the collision. Now, the momentum before the collision is 20 kilograms meters per second, which will be the same after the collision. Before the collision, we have 10 times 2 plus 0, which is 20 kilograms meters per second, and after the collision, we have 5 times v. 5 is the mass of the smaller ball, and v is the velocity we need to find out. Now, after some simple equation and algebra stuff, we find out the velocity is 4, which means that after the collision, the smaller ball, which is 5 kilograms, is moving at 4 meters per second. A real-life application of momentum is really common. For example, during a car crash, if it's a head-on collision, both cars will stop because most of the time their momentums cancel out each other because their momentum is from opposite directions. If it is a rear-on collision, a car in the front will go flying out because the momentum from the car behind will add up to the momentum from the car in the front, which causes it to have pretty much double the momentum.